And here is my research that I've been working on. I've been looking at algebraic reasoning and problem solving. So let's get started. Solving course, and I created the database of questions, these story or word problems, as we've been looking at in our course this semester. And I really thought about, well, a lot of what we do in those particular word problems is really using those algebraic reasoning skills, but also looking at problem solving and how to really foster that in our classrooms. I've been teaching for many years, and I know that word problems, story problems, are the hardest part about mathematics because you have to be able to look at this almost sometimes a paragraph of information and pull out those particular skills. For me as a student, that was the toughest and most challenging lessons or parts of homeworks or projects to do because I didn't really know or understand what problem solving was. So it's the one thing that I always look at when I'm teaching is to slow students down to really look at how am I as a teacher going through and pulling this information out and modeling those skills as much as possible. Other pieces that really just stuck out to me is that, we are generalizing, and generalizing is an art. I find it very tough and challenging to go through and kind of look at a particular problem, especially in our developing thinking in algebra, and saying, oh man, like, how do I make a generalized statement to be able to apply the next time I see a problem like this, or to be able to kind of use that as part of my toolbox. So all of these kind of pieces is really what helped me focus in and find some research and studies and articles just out there to see kind of where I could go from there. This quote really stuck with me as I wrote my paper. I'm just going to read this and then just explain and bring it back to my students. The process of algebraic thinking means generalizing mathematic ideas from facts, compiling generalizations through statements, and expressing these statements in a formal way, and according to developing the developmental age of students. This really stuck with me because of the fact that I feel that certain students have really good problem solving skills and have really good ideas of how to work with numbers, and they see the patterns. They're able to generalize a lot quicker. And then I see students who have a very hard time because they don't have this basic foundation of understanding of numbers. And I feel that over the years, as I've taught, and I've just primarily taught high school, is that every time I get a new batch of students, especially freshmen going into this, Algebra 1 classes, or in past years I've been more into pre-calculus and geometry, as they lack these skill sets and the ability to even transfer their own skills to one class, one content, one lesson to another lesson, to an activity, or even kind of looking even farther ahead and saying that the skills here, these problem solving skills that we're learning here, this is going to help you in science class. And they don't see those connections, and it's very, very hard. But then I have to go back and think, well, they're not there yet. We push students so much to say, all right, you are now going to take algebra, but they're not ready for it yet. They're still exploring all of those pieces and evidence of what numbers are and what connections we can have with patterns and all those different pieces. All those algebraic reasoning skills just aren't there yet. We want our students to get to algebra, but some of them, they may not. They might not be ready to take algebra until they're a senior in high school. And that's okay because everyone processes at different rates. So as I was reading these articles and really just kind of gathering, I came to kind of really three general conclusions and pieces that just linked all of my research together. So confidence levels. So what I thought about a lot is that even as a learner myself, being confident in what you're doing really helps you to be able to explore the math that you're doing. In the math courses that we've taken here at Ball State, I feel that we've been able to kind of given time to really explore. Sometimes I feel like I don't have enough time to explore everything that I'm learning, but I'm able to try and look at it, make mistakes, and it being okay if I made a mistake, because there are at times maybe 4 different ways or avenues to get there. So looking at my students and their confidence levels in math, they look at math sometimes and they're they're not confident in themselves because they always say, I'm not good at math. I can't do this. So when you see a word problem and they already struggle enough just maybe trying to solve a one-step problem and looking to solve for X, or trying to figure out, if this expression, what values I could plug in, what would make sense in a real world situation, that if they don't have a supportive environment, they cannot be confident in their problem solving skills. So that is one area that I kept seeing, looking at having that supportive environment so they have that time to practice. And that's the other key. You need a lot of time. And when we were looking at even that database that I keep referring to in the class last spring, is those problems take time. And some students can go through and say, all right, I got this. I know I can do this. They can go online, they research, they maybe find a formula that they can utilize. Maybe they ask the teacher, do you have like a resource online that you can just show me that maybe it'll help me kind of kickstart what I'm thinking? But then you have these other students that don't even know where to start. And then trying to figure out, all right, what kind of, questions are they going to ask and how are you going to answer them? That was the other key piece last term, was that how can I get my students to get to their answer and their conclusions their own way without leading them on my path and how I solve that particular problem. The ability to question is super important for students. If they don't have time to process it and then look at it and say, all right, yeah, I understand this. I get this. I know what to do next. In my current role at the current high school, I'm in a virtual setting and I'm teaching live lessons. And the one thing that we do is we pause and we give students a moment to say, all right, well, here's the information. Here's an example. Here's the definition of these particular problems. And then now try one. All right, do you understand is our next slide. And if they're at the point where they don't understand, then we need to know that, and they're able to kind of articulate and saying, oh no, I'm really, really good, or no, I have no idea what you're talking about right now and I need some extra help. Or I'm okay, but I'm in this kind of stage where I need to have more practice, and we're able to prepare them to kind of get into there. The other piece, and I have someplace, is a sign that says, making mistakes is part of the process, right? Students a lot of times, especially in math, and this is what brings their confidence levels down, at least in my experience, is that when they make a mistake, they say, I didn't get the answer correct. I'm not smart in math. And what I've trained myself to say, even to myself, because sometimes when I struggle with a math problem and going through these different processes, that I don't get the right answer the first time around, but then I tell myself it is okay because I just found one more way of not being, finding that error, as you're going through. And then I've now kind of can start this new journey saying, well, I need to make sure I watch out for this particular part of the question and how I'm answering it. And I need to not do that again. And you actually train yourself and you find your mistakes, but you actually own the mistakes because that's an important part of your learning. So for me, the confidence level, that's what just kept one of the three major topics that I kind of looked at was that, my students, if they're confident, they'll try anything and we can get them to where they need to be. But if they don't trust you as a teacher and they don't trust themselves to make mistakes, to ask questions, to take the time to practice, and you don't support them in that environment, then they're not going to be confident like they need. Has available a powerful tool to support students in their building of mathematical ideas. And what really this is that when we're problem solving and we're within a class and we're providing these students with time to practice, we model what we want them to do. We model how they should be questioning, maybe asking a probing question instead of giving them the answer. Students want the answer so they can just move on. They live in this world that it's an instant gratification, right? It's instantaneous. I'm going to get that answer right now. There's so many apps out there that scan a problem and you get your whole entire solution. They see it step by step, but they don't experience the steps or make mistakes. They just have the right answer and they move on. So they're not learning and they're not problem solving. They're not trying to ask the right questions. So as I could have looked at my role as an educator with my students, but also just in general, is that you need to have a piece where who have some type of intervention, whether that's more time, whether that's reteaching, providing students an alternative way of doing that particular assignment, because sometimes lessons and activities do not, actually work out the way they're supposed to. But if we model that as teachers, that here, this didn't work out well, but we're going to try it a different way, or we're going to go in and take some time to practice this or reteach that to them. I know that if I make a mistake in class and I get called out on it, I'm like, thank you for watching and paying attention to me, because if I'm making this mistake, this is a mistake that you could make as well. And it's important that students know that even as an adult, if you make a mistake, it's okay, because I'm learning too. Differentiation, our students are at different levels. They process problem-solving skills, algebraic reasonings, being able to generalize, when they're looking at those particular problems. So we really need to make sure that we're doing that in our classes, so that way, as a teacher, maybe not, and being careful about how we differentiate, we're trying to teach them how to problem solve. We may want to show them step by step on how to do a specific problem, but at times maybe being less general and giving them a chance to teach each other, to be able to kind of find that avenue. And this is the part that is hard for me, because I don't want them to struggle, but they need to struggle a little bit, so that way they can feel confident that they can figure it out. And the scaffolding piece, I've been scaffolding assignments for a decade, or almost 2 decades. And what I find is that that's super helpful, but you almost have to be very mindful of how much you're scaffolding. We could almost end up scaffolding so much that we're not even giving them a chance to actually discover on their own. So I need to be mindful in that, and how, as I go on and kind of teach my new classes and my new role in this virtual setting, is how can I manipulate my content so that way they get to problem solve and they get to try these pieces on their own too. The other piece for my students, so student reflection and feedback. Students need to reflect on how they're doing in class. They need to have that ownership, and this quote I think kind of just sums it up. Ownership of mathematical activity means that the students' mathematical ideas, representations, justifications, and decisions are phased over those of teachers, researchers, or other experts. So in this particular study, they wanted students to feel the ownership, and this particular, I think this was the longitudinal, this was the longitudinal study, that students were actually with these researchers for 10 years, and they followed them, and the students were saying that, when I first met you, it just didn't, wasn't confident, I didn't do this, but now I've practiced enough that I really feel confident, and I feel good about being able to tell you how I'm doing. And that's part of that growing and learning process there. And by having students take ownership of their learning, now they're in charge. So when you go and say to them, and you've got that nice culture in your classroom, is that they're able to go and explore and try new things, and be able to say, oh man, I made this mistake, or I got the wrong answer, but the partner that I was working with, they got the right answer, and they were able to help me kind of see what mistakes I was making, be able to reflect and look at what they're doing and what's next for them. And educators should reach out to their students for feedback. At times, I think some of us are afraid to ask students for their feedback, but they're the ones that are obtaining this new information from us. And I think it's really important that we ask our students, how are we doing? And some of them might say, well, I really don't like the consistency of this, or doing this all of the time, or, I liked it when we did this particular piece and mixed it up a little bit. And as an educator myself, I've learned that, yes, I just need, even if it's informal, how do you like this, particular unit? Is there something that we should change? How should we go about doing this? And if we do that for our students, they're going to know that you actually care about how they're learning and care for them as a learner. And that's very important in a classroom setting. And that just kind of goes back to, and loops back, to having that supportive environment for students to be able to make mistakes and to grow as a learner. So in conclusion, so what's next for me? So I want to really continue to kind of look at ways of incorporating problem solving into my my classroom and for my students. So that way they can actually just continue to work on those particular pieces. The other pieces is to develop some activities and problem sets to encourage problem solving. So I really want to kind of look at what I'm doing this year in my geometry classes to see if there's a way for me to help students develop those problem solving skills in a different way. I'm doing some great work right now, and the school I'm working with right now has a lot of just data that we're collecting, and we utilize that to help make sure students are placed, but also to make sure that we help them fill in the gaps that they have. So I'm very excited about that piece, but I'm also excited about being able to say, oh, here, I want to flip this a little bit. I want to change this, or I want to just develop my course in a different way. So utilizing all of these different tools is what my plan is, and I want to kind of keep doing more work with problem solving, algebraic reasoning, and maybe even look into more geometric reasoning as well, to kind of see how I could help my students in that front as well. I'm looking forward to hearing from you all and feedback and what I've learned and what I'm very excited about continuing to go and grow as an educator. So thank you for listening.